Supervised learning. Supervised learning is like teaching a toddler, except the toddler is a GPU that costs more than your car. You give it examples, you give it answers. This is a cat, this is a dog, this is a cat pretending to be a dog on the internet. It's like showing your intern exactly how to do something 10,000 times and then acting surprised when they can't handle one new scenario. In reality, it's a type of machine learning where the model learns from labeled data. For example, you feed the model a big stack of animal images already labeled as cat, dog, or rabbit. It studies those samples, learns the patterns, and when you show it a new animal image, it confidently says, "Yep, that's a cat." When it predicts continuous values like prices, temperatures, or how fast your code will break, that's regression. And when it sorts things into buckets, spam or not spam, cat or dog, human or definitely an AI, that's classification. It powers spam filters, voice assistants, and Netflix recommendations. Basically, the algorithms quietly judging your life choices every day. Unsupervised learning. Unsupervised learning is what happens when you take away the answers and just tell the AI, good luck. It's like watching a junior engineer explore production data, blind, confused, and somehow accidentally successful. Here, the model gets unlabeled data, no instructions, no labels. For example, imagine dumping hundreds of unlabeled pictures of cats, dogs, rabbits, and a raccoon. It has no clue what any of them are, so it starts grouping images that look alike. That's clustering, where cat photos end up with cats, dog photos with dogs, and rabbits with rabbits purely based on visual similarity. Then it compresses that overwhelming visual chaos into something your CPU can actually survive. That's dimensionality reduction. You'll see this in customer analytics, fraud detection, and recommendation systems, basically turning your pile of nonsense data into something that kind of looks smart on a dashboard. It's creative, chaotic, and absolutely convinced it's found meaning. Semi-supervised learning. Semi-supervised learning is what happens when your dataset is half smart and half clueless. It's like watching a senior engineer solve problems while an intern offers emotional support and syntax errors. You've got a few data points that actually know the answers and a giant pile that's completely lost. For example, imagine a folder of animal images where only a handful are labeled cat, dog, while the rest stare blankly at the model. The model uses the few labeled examples as a guide and tries to teach itself the rest. Images that look like the labeled cats get classified as cats, similar looking dogs become dogs, and the leftover floppy eared creatures finally get recognized as rabbits. This blend of a small labeled set with a large unlabeled set helps it learn faster without you manually labeling every single image. It shows up in speech recognition, medical imaging, and fraud detection. It's part genius, part guesswork. Like a developer who read half the documentation and decided they understood the entire API. Self-supervised learning is what happens when the AI becomes its own teacher. It's like dropping out of school, writing your own textbook, and still giving yourself straight A's. You give the model unlabeled data and no instructions, so it makes up mini puzzles for itself, predicting what's missing, filling in the blanks, and pretending that's progress. It's machine learning's version of talking to itself in the mirror until it believes it's smart. The model invents its own labels, predicting what's missing and pretending it's feedback. Basically, it learns by solving tiny puzzles inside the data until patterns start making sense. This method shows up in massive models like transformers and language models, the ones that predict the next word. It's behind GPT LLMs, DLLE, and those smart cars still learning what a stop sign is. It's smart, self-driven, and 100% sure it's changing the world. But when you stop letting it study quietly and start rewarding it for trial and error, that's when reinforcement learning takes over. Reinforcement learning is what happens when you teach an AI through trial and error, reward it when it gets something right, penalize it when it messes up. Imagine a digital dog in a simulation learning to fetch a ball. Moving toward the ball earns +1 reward, picking it up earns +5, and running into a wall loses points, and possibly dignity. At first, it behaves like a confused Roomba, bumping into obstacles, spinning in circles, and making life choices no one understands. But after thousands of retries, it finally learns ball good, wall bad, and starts fetching like a pro. You'll find it behind robots that walk, drones that fly, game playing AIs, and self driving cars that almost get everything right. And that's a wrap. See you in the next loop.